Greetings. This video is for Calc 3, section 15.2. It corresponds to number 10 in our book homework, but it's number 5 in our online 15.1/15.2 iterated integral section. So this question asks us to find the iterated integral from 0 to 4 with respect to x, and then from 0 to 12 with respect to y, of the function 4e raised to the x plus 3y. So what I'm going to do to get out of trouble later on is I'm going to rewrite this exponential as a product instead of having the exponent as added. So 4 times e to the x plus 3y is the same as 4 times e to the x times e to the 3y, and then dx dy. So what did I do? Well, I took this term and algebraically wrote it like that. It's multiplication instead of the addition in the exponents. So what that's going to allow me to do then is separate the stuff that I'm going to do first, which is dx. So the only thing I have that I'm worried about is this x. This 4 and this e to the 3y I'm going to treat as a constant. So then I'm going to integrate the outside, just recopy 0 to 4, and I'm just working with this inside part with respect to x. This outside part I'm just going to recopy with the dy. I'll just recopy that over here. I'm just working with the inside part with respect to x. So that would be 4 times e to the 3y. Those are constants, and I'm going to pull the constant outside the integral of 0 to 12 e to the x dx. So that's what I'm working with on the inside, and then I still have this dy from the outside of the iteration. So 0 to 4, the outside of the iteration, 4e to the 3y. Those are just constants with respect to x. Now I need to find the antiderivative of e to the x. I'm actually working on this integral now. These are constants I just recopied. The antiderivative of e to the x is e to the x. So this is e to the x, and that's going to be evaluated from 0 to 12, and then still dy. So this is evaluated from 0 to 12, still times dy. Okay, so let me write that. 0 to 4, 4e to the 3y times, and then e to the x, I'm going to put in the 12 with the fundamental theorem is e to the 12th. And then minus from fundamental theorem, and then e to the 0, and then dy. So fundamental theorem of calculus says I apply this, and then I have a subtraction sign, and then I apply the 0. So that can simplify just a little bit. So now I have the integral from 0 to 4, 4 times e to the 3y times e to the 12th, which of course is just a constant, minus e to the 0 is 1. So that's what I have. This term is a constant. This is a constant. So I'm going to pull those constants outside. So I have 4 times e to the 12th minus 1. And then the integral from 0 to 4 of e to the 3y dy. Once again, constant, pulled it up front, constant, pulled it up front. I'm left with e to the 3y. And now I can just deal with that antiderivative. So 4e to the 12th minus 1. And then the antiderivative of e to the 3y is e to the 3y divided by 3. So times e to the 3y, all divided by 3. Evaluate that from 0 to 4. So I have 4 times e to the 12th minus 1. And then e to the 3 times 4 from fundamental theorem of calculus divided by 3 minus e to the 3 times 0 divided by 3 from fundamental theorem of calculus. And I can simplify that. This is 4 times e to the 12th minus 1. And then this is e to the 12th divided by 3 minus 1/3. Because e to the 3 times 0 is e to the 0. E to the 0 is 1. Still divided by 3 is 1/3. So that's really my answer. I could put that down and would be fine. This can be simplified though. So I have 4 e to the 12th minus 4. I multiplied that in, the 4 in. And then I have e to the 12th divided by 3 minus 1/3. And if I FOIL that, I have 4 e to the 12th times e to the 12th divided by 3 is 4 e to the 12 plus 12 is 24 divided by 3. That's this term times that term. Then I need to multiply 4 e to the 12th times minus 1/3. So minus 4 e to the 12th divided by 3. That's this term times that term. Then I need to take minus 4 and multiply it by e to the 12th divided by 3. So that's minus 4 divided by 3 e to the 12th. And then finally I have this term times that term, so that's plus 4/3. And that's also correct, but I can simplify each more. I see that each term has a 4/3, so I'm going to factor out a 4/3. In the first term I'm left with e to the 24th, and then I have, this is factored out, so I have minus e to the 12th. This is factored out, so I have minus e to the 12th. 1 minus e to the 12th plus another minus e to the 12th is minus 2 e to the 12ths. Remember, this is 1 here and 1 there to make negative 2. And then the 4/3 and the 4/3 get factored out. So it leaves me with negative 2 e to the 12th. And then finally plus 1. And I think that's the simplest that our answer can get. Okay, I hope this video helps. If you have any more questions about these iterated integrals,